So my name is Nia, and I work at a company based out of New York called Healthy. We do health administration sort of stuff. So we work with doctors and nurses, and whenever you go in to get their charting information, that's sort of the software we build. Managing front-end tech debt, yeah, a little bit about me, like more about me besides where I work. Originally, we lived in Atlanta, and I started my career with startups, where I got to do all the greenfield work, you know, the brand new spanking GitHub repo. Nobody else's code was beautiful. And then as I progressed in my career, I started working with more mature startups. So for example, Healthy is a company that's been around for about 10 years now, or 10 years. That means there's a lot of legacy code, and now my job is no longer greenfielding stuff, but managing other people's code and managing how we handle legacy code. So going back into the talk, when we talk about tech debt, anyone who's got some tech debt, their reaction usually is this. Because yes, tech debt sounds miserable. The reality is we all deal with it. And out of this whole talk, if you stop listening to me and you go onto your phone, just take a picture of this slide. That article literally changed my perspective on how I deal with tech debt. And most of my job right now as a front-end architect person is literally managing large-scale amount of tech debt and figuring out how to fix them so we can build new stuff, right? And this article, in fact, I literally plagiarized this article for this talk. That's literally what this talk is all about. They give a lot of strategies as well. I've found some of the strategies useful, but at the end of this talk, I'll give you my opinion on which ones worked and which ones didn't. So what we're going to talk about here is common assumptions we have about tech debt. The types of tech debt, because the reality is if you can put them into boxes, the different types, and categorize them, they're less scary and they're easier to manage. And the last bit, strategies for handling tech debt. That is, I would say, more my opinions on what worked for me, not so much like you must do it this way. Now, common assumptions about tech debt. When you hear it, we all think it's bad, it's complicated, it's not product work, and developer pain is the same as organizational pain. So let's kind of dig into that. We all kind of course, know these things, you know, because we're all smart people, we all know this, but what does that actually mean, right? Tech debt is not bad. It literally means you've succeeded to have tech debt. Yes, question?
Oh, just for like the junior people, what is tech debt?
Good question. Tech debt is when you've written enough code that you can't write something else because you still have to deal with your old code. It's sort of like you started building your application, you started building your structure. You said, we're going to put a bathroom in this corner, the kitchen in that corner, and now, I don't know, 2 years later, you're going to say, oh, we need to build a new level with a different bathroom structure. How do you restructure the foundation? Right? That's how you have to think about it. It's, for example, Intuit, I'm sure, has a lot of tech debt as well. As you become more successful, you have it. Every company out there has tech debt. It's the idea of managing your old legacy code so you can still build and produce new features and build new stuff with the new latest tools, right? So that's where that is. Tech debt is not bad. It literally just means you've succeeded. You as a company, as a product, have got people using you, which is, in the startup world, freaking amazing, because you are no longer sitting around waiting for a user, right? It is the mark of progress. It means you've progressed as part of a code base where you're no longer just greenfielding everything. You've got to think about things architecturally. If I make a change here, how does it affect all these different other places, right? And how do I set patterns that can be reused? So that's one of the big things. And not all tech debt is equal. By breaking them into smaller categories, you can kind of figure out better tasks. So that's what we'll talk about in the next bit as well, about how to like put them into boxes so you know what you should handle when, kind of thing. So yeah, applaud yourselves if you've got tech debt, because you've actually succeeded. Now, tech debt is not all complicated. Some tech debt is as simple as just saying, we are all agreeing now to do it this way rather than doing it that way. That's really it. And then you start small changes, right? Most people, when they think about tech debt, this is sort of what they're thinking. I touch that one jQuery string and 500 different things breaks, and I don't know how and why. The reality is, if you can break them into smaller chunks, scope them into smaller pieces, they tend to be easier to attack and work on. So that's where this concept of defined versus undefined comes in. Defined work is basically anything you can put an end date to. And undefined is those larger pieces, for example, major library updates. You don't really know if you can update major library if you've got 5 years worth of code sitting there, because if you've got 7,000 files of code and you're just updating a library, the syntax might be changing, or how the library compiles might be different, and that may break things in unexpected ways. So now that is undefined because you just don't know what's going to break until you go poke it, right? So versus defined work can be something as simple as, we all agree now, we're going to start doing documentation. That means anyone building a new component is agreed to writing the small snippet of documentation. It doesn't need to be this large-scale project. It could be something we just start as a new practice, and so it's got a clear start and a clear end to it, right? Tech debt is not product work as the other assumption, but here I'd say tech debt is product work, because the thing is, you can't build new stuff if you don't deal with it. Eventually, it'll become so hard to build anything, you'll be stuck with having to rewrite the whole application. And that's the worst place to be, right? And the best way to communicate this to product people is to tie it to business jargon. Frig, we all now have ChatGPT. Use that to get some business jargon. That's literally what I do. Is I figure out, how do I communicate this better to the product people? How do I make them understand why this thing needs more time and resources to be fixed, rather than just building on top and getting the next feature out, right? So why should they spend that time there? One of the things to think about it is as money, really. The more code we write, the more tech debt we accumulate. So just like businesses taking credit, right? Eventually, you have to start paying off your credit before you're fully in the red. Ideally, you don't go too much into the red, because once you're in the red, you're bankrupt, right? So, and the idea here is to always sort of pay off enough of the tech debt that you can keep doing better things. So if you've got class components and you're moving them into functional, pay off enough that you can move to the next place. And this is sort of how you communicate these things to the product people. Developer pain is not organizational pain. This is sort of the hardest one for me to deal with, because I'm building something and I can clearly see this thing is going to take me hours because some other idiot wrote this thing, and that's so much harder to fix now. So because I have to deal with their old shitty code, I'm now struggling with my code, right? But is that technically the business problem, or is it just my problem? So you kind of have to accept it. If you've got a successful product, you're gonna have to live with that pain. The key there is empathy, right? Good way to figure out is this is a large-scale problem versus a smaller problem is to ask the questions of what is the impact on this for users? This feature that I'm trying to roll out is taking me 10 times the time because I have to struggle with this. But is that worth it for me to go fix that everywhere, or should I just suck it up and do that job, right? The next bit is, do other teams also feel that pain, or is it just me? Am I the only one seeing this problem? Is there a reason why things are the way they are? Sometimes, yeah, that's a horrible piece of code, and you want to fix it, but there might be a good reason why it's a horrible piece of code there. For example, with my company, they started using TypeScript before that was a cool thing to do, which meant a lot of libraries didn't fully support TypeScript yet, but we were still using those libraries. So we have some really bad use cases of any everywhere, which, frankly, yes, it's painful. Now we all know not to do that. But when they first wrote it, there was no one to tell them that, right? It was a good way of getting forward to be able to use libraries and still build stuff. But of course, now when I look at that code, I'm like, who the fuck wrote this? But, And the last bit is, does your leadership understand why Oh, it died. Of course. So I think somebody just needs to occasionally move the cursor there. The last thing is to make sure the leadership understands the value of fixing whatever that tech debt is. It doesn't matter if it's it could be something everyone's feeling. It could be something that's impacting users. It could be something, there's a good reason for why it's there, but now it needs to be fixed. But if your leadership is not on board, you're wasting your time. You're fighting uphill battle there, right? And frankly, in some of those cases, your options may just be to let it go or find a new job. Now, I've preached to you about what tech debt is and how to look at it and all the assumptions. Let's talk about categorizing the beast there, right? So types of tech debt. So maintenance, developer efficiency, stability, security, technical product and decisions, basically. Maintenance is things keeping up to date. So library updates, changing of syntax. So we've all used to use high-order components at one point, and now we're all using hooks. We also used to use in React World class components, now we're all in functional. That means for legacy structures, somebody's got to go back and rewrite those things, right? That's the maintenance part before you can upgrade libraries. Documentation, that's another big one. So maintaining those documentation, making sure as your components change, you update the docs to reflect that. Developer efficiency, engineering workflows that are bogged down. So figuring out areas of code where you're much slower in building, right? So some good reasons for this could be feature testing. You need more RSpec, like feature testing, Cypress ones, or like full end-to-end testing, or even unit testing, right? Developers can't do experiments to verify their ideas. So like for us, for example, there were specific areas where we knew we were weaker on the feature test. We just didn't have enough looking at all the features. So touching it meant we couldn't be sure it wasn't breaking something else. So that means writing those tests is part of the efficiency work there. Stability debt. This is the place, basically, if you're in your code base and there's a space you're terrified to touch, because you know if you touch it, it'll break 700 different things in different areas of the world. That's a problem. We've had a few of these, and the best way to handle them is usually to start talking about writing tests, talking about rewriting that code, maybe even updating some of the syntax, right? So one good way of knowing this is a stability problem is where's all your bugs coming from? Is it that one area? Does people changing code in that area cause bugs in other areas? It's a good indicator that it's a stability problem, that it's affecting overall architecture rather than just that specific area of code. And then technical product debt. This is basically the hard one to kind of figure out, because it's never just one thing. So it's usually the stuff that the product people usually see first. It's the bugs that you see first. But it could be performance issues maybe, right? But the reality with performance issues, so one of those is it may be due to a stability debt or something else under the scenes. So with this one, these are the vague ones that you can usually categorize together. And it's usually caused by other types of tech debts. And the last one is decision debt. This is the one I personally struggle with because it's somebody else's decision now that I have to live with, right? And as you grow in your careers, you're probably going to have a senior developer telling you, no, we're doing it this way, even though you disagree. But this is part of building applications is looking at the pros and the cons and being okay living with some of those cons, right? So for example, with us right now, we have high-order components everywhere. That was the hot thing to do, 5 years ago or so in React? And it was really useful when we first did it with TypeScript, as well using it with any's and stuff. It made us go faster. That was, at that point in time, the people who made that decision were okay dealing with the fact that the props sometimes re-rendered when we didn't expect them, or the fact that the TypeScript any technically nullified TypeScript. But those were decisions somebody else made, right? And now you know why they made it, you can deal with it with some kindness. The thing is, you've got to think about it as a boat. We're all in the same boat. We're all trying to build a good product, and we're all trying to do the best job we can. So instead of being angry at the fact that someone did a horrible job with the TypeScript or the high-order component, You got to think about it as they made a decision that helped us survive this long. Let's make a new decision to fix that, right? It's all perspective for this. Now, we're moving into the stage of opinions. So the strategies of how to deal with tech debt. Now this, I'm specifically saying it is my opinion. It is not fact. It is just a few things that have worked for me in how I communicate with the business side, with the product side, and with the design side, and how to navigate when do we fix things, right? The two things that have helped is quantifying the size of tech debt, and then prioritizing when to work on it. So for new developers, it's basically do you pick which problem to fix first, right? Is it important now to fix it now, or do I have to, how big of a problem is it that I have to fix it later, right? So sizing the tech debt, there's acute versus systemic. A good point of acute is anything that's pretty small. Within a day, you can fix it, right? So for us, we implemented every new shared component would be part of a design system. We would have Storybook, and you have to write a Storybook doc before that component goes out. Pretty small thing to do for now. We didn't have to go back and fix everything. We could just do it with every new component we wrote or any new component we touched. So that was fairly acute in the sense that we could roll it out with each feature, right? Small problem to fix. And going back after the sprint, we could also go back and adjust the documentation kind of thing. Systemic is a huge undertaking. Those tend to be where the undefined problems tend to be, right? They tend to be large epics of work. So for us, one of the things that I'm currently working on is shifting us out of high order components. I have over 400 tickets for it. That means I can't give them a deadline of saying, I will be done by this sprint, but I can tell them this is the progress we've made. It's over multiple sprints, and this is how we're attacking it, right? So I can still give them a size of it, how big the problem is, what are the things I need to do in order to get to that problem being completed. What does the end date look like, right? Now, ways to prioritize. The first is confidence. So giving size to your tech debt problems gives you a lot more confidence. I can now talk to my product people and say, yes, I know you want this feature now, but if you let me fix this one thing and take an extra 2 sprints, I can give you this feature plus the next feature will be easier. This is how you do it, right? So sizing things gives you that confidence to say, this is what I need. Another way to get confidence there is adding more tests. These are all different strategies to gain enough confidence to say, I can fix this within this time frame before it takes any more resources, right? The next is time. When will this actually be a problem? So remember earlier I was talking about, is this an organizational pain point or just my pain point? Yes, I'm working on this one area and it hurts, but is this necessary to fix this tech debt now, right? There are some tech debt that you can just sit with for a few years before you actually have to fix it. So for us, the high order components were not a problem for a long time because a lot of libraries still supported it, right? But now it's time that we have to fix it because a lot of libraries stopped supporting it. User impact. How does this affect users? This is the part that you can usually use to get buy-in from business, buy-in from your product people. If you can talk to them about how this affects the users, and at the end, how it affects their margins for profit, right? How will the tech that they're sitting there cause long-term problems? So for us, with the high order component one, it was easy to talk about they wanted a new feature. We can't actually add that new library in that feature because it no longer supported high order components. So that's a clear user impact, right? The last one's a sequence. Reality is with bigger code bases, there's a lot of different kinds of tech debt all happening at the same time. So how do you sequence things? How do you pick which battle to fight first, right? This is sort of the one where you're going to have to spend some time investigating. So for us, I spent a good quarter just poking at things and making sure they failed or not, understanding what was happening where. So I understood one of the key things was before we touched our high order components, I had to get docs in place. I needed to understand how many components we did have. I had to get tests in place because I needed to make sure if I broke something, somebody would tell me before it goes out in production. So those are some things of sequencing that before I started attacking the main problem, right? And the last thing is accumulated tech debt, right? How much debt do you already have? Can this thing actually wait a little longer? Are you starting to go into the red, right? For larger companies or larger products, the longer they sit with the accumulated tech debt and as it keeps rising, the sad part is you're going to get stalled if you don't fix it. So as you start maturing as a product, you have to start thinking about things in patterns and large-scale architectures rather than just this one side of implementation now. I'm just releasing this feature now. No. What you're releasing is a pattern somebody else is going to follow, and are you okay with that pattern being copy-pasted 100 times without any control, right? So that's how you got to start thinking about it and how you accumulate that debt. Another thing is, strategy-wise, that's helped with this accumulation, like slowing that down, is I know right now the hot thing is hooks. Everyone loves it. And I know before we had something else as the hot thing. And the reality is trends in JavaScript world in the front end always changes. They change every fucking month. And I'm just barely holding on. And most of the front enders feel the same way. Screw it. Like, keep it simple. Remove abstractions as best as possible. Like, keep it verbose. Keep it as close to vanilla JavaScript as possible, right? So with one of the things we've done specifically is no custom hooks. We use native built-in hooks from React. We use native built-in hooks from Apollo. But we don't build our own custom hooks because it's the same pattern as hooks. It's the same problem as hooks. You're going to get into the same problem where if React decides we're no longer doing hooks, maybe 4 years down the line, you're going to have to rewrite all of that. But if you keep it everything native and very simple JavaScript, debugging it becomes easier. We understand exactly when state re-rendered. We understand why something changed. We're not worried about the hook like re-rendering things randomly. And changing syntax becomes a lot easier. So yeah, now this is basically the end of my talk. I just wanted to say, like, congratulations for any of you who have tech debt. You still got a job, because the more tech debt you have, the more problems you have to fix, and the longer you get to keep your job. So I like this one that says, the only problem we really have is we think we're not supposed to have problems. Problems call us to higher levels and face and solve them now. Literally, the reason we all have jobs as developers is because somebody had a problem they needed to fix. And it's easy to hate on tech debt, but it's like happiness. It's not the goal, it's the journey. And as long as you still have something to solve, you have a job. Questions? Thank you. Sure.